Okay, I think it's time. Well, welcome. This is Mongo for JPA Developers, in case you're in the wrong room. I am Justin Lee. That's really loud down here. My name is Justin Lee. I work for MongoDB. As a member of technical staff is technically my title, whatever that means. I've been doing Java since '96. I work on specifically the Java driver and Morphia, which we'll cover both of today. And in previous lives, I was a member of the Glassfish team, so it's been a bit of a sad week for some of us this week. But I did the WebSocket implementation, and I've been doing EE since '98. I mention all that primarily just to say is like I don't hate Java EE. I have deep, long roots with it. So a lot of people, I don't know, try to bash one thing over another. I like both equally well, and I'm actually quite interested in seeing EE and Mongo work together. So just that little caveat. But yeah, so I've been doing EE since '98 ish. It wasn't technically 1.0 EE when I started, and the company I worked for, we built our own ORM, which was a terrible idea, but we didn't have any better options. And I've tried to forget it since then, but here I am 12, 15 years later, something like that, and now I'm writing another one. So anyways, I'm going to try and see everybody here. Who has used Mongo before? Oh, lots of hands. Okay, good. Well, I'm going to do a brief little tour through some of the shell and syntax and what Mongo exactly is, and then move on into code. So I don't want to dwell too long on one or the other, but context helps. So Mongo, the name comes from humongous, which means big for the non-English speakers in the room. I prefer the Blazing Saddles connection, but that is entirely in my head. It is a scalable, high-performance, open-source NoSQL database, which is very buzzwordy. But it is a document store as opposed to a relational store, which we'll get into. The kernel itself is written in C++, but we have drivers in almost any language you care to think about. We probably have either are writing our own driver in it, or we have community support writing the driver in it. So yes, so it is document-oriented, so we don't store things in rows like we would in an Oracle database. We store things as contiguous documents. It's fully indexable in a number of different ways. We support the standard indexes, by strings and numbers and whatnot that you would see in a database. We also have text indexing, if you want to do text searching, and we also have geospatial indexing, if that's what your application needs. We support replication and high availability in a number of ways, and we'll see that briefly later. In terms of getting your data back out, as opposed to just doing straight queries, we also support MapReduce natively inside the Mongo server. Not the best option necessarily, but it's there. And we also support the aggregation framework, which is new in 2.4, which is the preferred way if you want to do complex queries and whatnot. That is the preferred way to do it. It is much faster. And Mongo also offers what's called GridFS. It's basically a way to use Mongo as a file system, so you can store files and images and whatever it is that you want to put into it. And there's actually even a Fuse module, if any of you guys are Linux, to actually expose GridFS as a native file system on Linux, if that's your thing. So what does it mean to be document-oriented? So in JPA, you put one object and it's mapped across cells in a row, right? Everyone's done that forever. But it starts getting a little tricky because if you have embedded entities, suddenly your table starts to scroll off the right-hand side of the screen. But we store the documents in, we call it JSON style because it's not technically JSON, and it's actually BSON, which is binary JSON for various technical and performance reasons. But we store them all in contiguous documents. And there's the spec if you want. So BSON adds some extra stuff to it to make indexing and searching and extracting your data out of the thing very, very quick, as opposed to JSON, which is just flat text, and you have to parse the whole thing to figure out what's what. So this is what a document looks like. inside Mongo, if you do a query, which we'll do here in a minute, you will get back a document that looks just like this. Every document will have that underscore ID field. That's the primary key. It can be whatever you want. It can be a UUID, it can be a string, it can be a monotonically increasing integer, if that's what you want. If you don't give it one, we will give it one for you of type object ID, which is reasonably globally unique. I'm sure there are certain cryptographic and security things that it doesn't quite work that way, but for the most part, it's almost impossible to create two object IDs on two separate machines that collide, which makes this ideal. Replication and high availability. Mongo is eventually consistent. There are a number of different ways you can make sure that your data gets written properly, depending on how secure you want to feel with it, but it is eventually consistent when you're talking about replica sets. So you write to a primary and you can have a number of replica sets that will then eventually get the data. Usually eventually means within a matter of seconds. But of course that's subject to network lag and contention of the router and those sorts of things. But we also support sharding, which is a way to split up your data in slices across multiple machines so that you can distribute your reads and your writes actually across different machines. So if you have a set of data that sees a lot of traffic, you can shard it, and then all the work needed to maintain that data suddenly gets distributed across multiple machines, as opposed to if you're not sharding, all writes go to the primary. So all writes will then have to funnel through one particular machine. But I don't want to talk about that too much because that's the subject of a whole other talk, and we are here to talk about Java, right? So we're going to look at some examples in the shell just briefly before we move on to code. This is what a query looks like. What you see inside those curly brackets is JSON-y. It's similar to JSON, so if you're comfortable with that, that should look just fine. But you'll notice that, for example, like this should be in quotes if it was really JSON, but it's not, because it's not JSON. So this is what that would look like. You noticed I put .pretty on it, because if you don't, it comes back and it looks like that, which is probably okay in some scenarios, but it's a little harder to read. So you can suffix any query with .pretty, and it will print it out in a way that's actually readable. This data is generated. It's a product database that was generated with random names off the internet, so please don't try to make sense of the names because there's nothing there. But that's a basic query, and in this case we're looking for any document that has the field fulfilled set to true, and there is that, as you can see. So that's, I was going to say that's as basic a query as you can get. You can actually do this, and it's basically a select star in any other database. But another query might look like, if you want a more complex query, you can do this. Now, with this one, it adds one more. Fulfilled is true, which is we saw, but then we also only want the orders who have 3 items in their 3 items in the order. So you have that, and you can add as many items to a query as you want, just separating them by commas like that, and it's implicitly anded together. Let's see what else we got here. Now, this one, if you want to look inside, if you remember when we looked at this other query here, you saw this array of products. But now, say you want to find how do I find a product with a certain name? In this case, we're going to try and find any orders who have products whose names are either QuadTech or BioLux. Sounds like a pharmaceutical order. But that's the syntax. And it can take a little while to get used to the syntax. It's almost kind of prefix notation, but it is, you get used to it after a while. It took me a little while, but once you get your head around it, it's actually not so bad. But as you can see, in this case, we got back exactly one document, which we've seen. So this is the same basic query. This is actually doing, it's a very similar query, but in this time we're asking specifically for that one product, or the one order with that one product, as opposed to an in query or $in. So that's what basically that's what the query syntax looks like in a very quick high level. You can OR them together if you're interested in that. You give it $OR and you give it an array of documents with different criteria. In this case, it's the same query we just did, except instead of anding fulfilled in the size, we're going to OR them at this point, and that should give us something very different. So, so those are the queries. If you want to do updates, let's look at just to remind ourselves. This is what the document looks like before we change it. But we are going to do an update, which has a slightly cumbersome. Let me do this. A slightly cumbersome syntax, but again, you kind of get used to it. So in this case, we're going to find everything with a size of 3. So every product with three items in the order, and then we're going to set the total field to 400. So we're going to change the total of the order. And then the last bit is just redoing the query so that you can see now, as you can see, total is suddenly 400 as opposed to what it was before, which is gone. So updates can be, you can do anything virtually to your document. This one here will actually add an item to an order. We're going to push some bobbles that are red. And if we do the query again, yeah, here it is. Up here you can see there's a new array called bobbles that has one document color red. So, and that's a very basic, yeah, we just did that, just to see the documents again. But enough with that. We're going to look at some code. I want to look over just briefly. I forgot to open it up first, but we'll do that right now. I want to look at a very basic JPA example just to kind of set some expectations here. So this isn't the best practice sort of a thing, but if you're going to model a product, it might look something like this. This should be, if you has everyone done JPA before, or is JPA new to you? Okay, yeah, so this should look pretty familiar for most of you. We're defining an entity, we're putting it in a table, we have these properties, never mind the double. We give it an ID, we're telling it we want to generate it, and you know, it's a pretty straightforward model, but I did want to point out, if we're looking at an order, one thing that's nice in JPA is you can do joins in a relational database. And so what I did here is I just defined a many-to-many, and these are all the products that were in the order. And then those are stored in separate tables for all your normalization needs. That'll look a little bit different in Morphia. So if we look at product order, it looks kind of familiar. We have an entity annotation here, and we give it a collection name. We talk about collections and not tables in Mongo, although if you hang around the office, which I'm sure everyone does, a lot of times we use the word table because we all come from that background too. But they are collections. But what I did here is you can see I actually embedded the products inside the product order. And that's for a number of reasons. Primarily is that we don't support joins in Mongo. We're a document database. You ask for a set of documents, and they all come from the same collection. And if you need external references, that's a separate query. So I can't do just a straight join with that. But also, what I did, you'll notice here, is I put in total and size. And that's different from the JPA version of it. You'll notice we just stopped at Boolean fulfilled. So if you look at the DAO inside this, again, this is kind of sloppy code, but illustratively speaking, hopefully it's helpful. So we're going to, we have a number of queries. This is just some cleanup stuff from these tests. So if we want to delete orders, we find them all, and then in this case, I'm setting the products to null for relational reasons. So if we want to find a user, we have a user in there somewhere as well. That's your JPA query. It's also very straightforward. Shouldn't be terribly surprising. But here's where the differences start to show up. So this is the query. Let me close that guy. This is the query that does, I want to find all the orders over a given amount. In the JPA, you have very nice things. You can do a group by so that you can sum up the price, and then you get the total. And that's possible because we can do a join in a relational database, and we can kind of tell the database, go do this work for me and get me back some stuff. But we'll see that differs a little bit. We want to find the small orders. In this case, we're doing a count of the number of items in the order. Again, with the join. And then I wanted to, this is, I do this partially, you really can't read that with this highlighted. I should stop doing that. Partially for comedic effect and partially just to kind of show. When you write a JPA query, you get some nice highlighting in there. In this case, this query works. But we'll see in a minute where it won't over in the Mongo side of the world. So coming back to Mongo, instead we have a DAO, and it looks fairly similar. I actually used Juice on this because it was simpler to set up the JPA context with Juice than it was to manually do it, which is a little sad. But so the DAO will look roughly similar. It has the same methods, find orders over this or that. But I actually have 3 different examples of each one to kind of show you what it might look like depending on how you want to do it. A lot of people actually use the Java driver directly, and that's perfectly fine. It's actually quite common. It is a lot of manual management of stuff, but you can do it for sure. So in this case, we are trying to save a Mongo entity, and this is using the Java driver directly. So in this case, we're going to create, I have some helper methods because it starts to get pretty big. We're going to create a DB object. So we're going to take our product and we're going to create, a DB object is basically a map, but it's backed with a little bit of BSON stuff. So in this case, we're taking our product and we're going to create a map out of all the properties. And then we're just going to take that map. In this case, we are going to generate an ID if it's a new product, so that it has it. The database will actually do that for us. It'll insert the document in it for us, but it won't necessarily reflect. It won't change your the state in your application, of course, because it happens on the database, and you don't get that back that simply. So we're going to create that. There. All right, so we've created a DB object that represents the product that we're trying to save. We're going to go get the collection, and this is just a helper method to actually go get the collection name off the product. I found myself writing more and more code to recreate Morphia as this code went along, and I couldn't stand it, so I wrote some helper methods. But anyway, so we're going to get the collection, and in this case, we're going to call update, and we're going to pass in the basic object with the ID from the entity that we're passing in, and then this is the document that we want to save. Now, true and false, these are 2 things. Hopefully you can read that. When you're doing updates, the default in the Java driver and in Mongo itself, actually, when you're doing an update is to update one document. So, which is nice if you make a mistake because you've only really screwed up your one document. But if you're thinking, I'm going to do this thing, I'm going to move on and get on with my life, if you forget to pass in true, it'll only update the one document and everything else will remain unchanged. People get tripped up on that a lot. It's a weird default, but I don't think we can change it now. So there's the update, and then we also have what's called an upsert. Upserts are nice because you don't have to do, you don't have to manually say, is this thing there yet? If not, go save it. What an upsert will do is when you pass in this case this is the query portion of it. If you'll remember from the shell syntax, you had a document that like saved, or size :3, you did a query to find the document that you want, and then another document that does a set of operations to update it with, and that's what you're seeing here. So we're looking for the object that has this ID, go get that wherever it is, and then update it with these particular operations. And in this case, they're just straight field sets. So that's how we're doing it. But what upsert means is that if there were not an object with that ID in the collection, the upsert would create that document for you, and it would set it with whatever is in your query here. So in this case, it would create a document with one field of an ID and then nothing else. But then immediately following that, it would apply your DB object, in this case, setting those fields to whatever the value is. So it's a nice kind of shorthand way of saying either update what's there or create a new document and save what I just gave you. So that's what an upsert is. So, right, this is a little bit different because product requires some weird things. Otherwise, you can pass on. This is actually a Morphia class, the data store, which we'll see. All right, so what do queries look like with the Mongo driver? So again, we're going to create a new basic object. We're going to call it total. We're looking for a field total, and now we need a comparison operation. So we're going to create another DB object, and we're going to use the operation $GTE, which is greater than or equal. All the operators begin with a $sign in MongoDB, so if you see a lot of queries with dollars, they are operations on a field of some sort. And then we're going to pass in total. Then we are going to get the collection, we're going to pass in that query. In this case, it's a very simple query because we're just finding the totals. Now, where it starts to differ here is because if you remember in the Mongo version, we actually stored the total on it because we can't do that summation in a Mongo query, at least with a straight query. There's two ways to get around that, and I wasn't sure I was going to have some code to show you, but I do, happily. Doing a straight query, there's no way to say, find this where the sum of that is greater than. With the aggregation framework, you can do that, and I will attempt to show you an example of that before we're done here. But in this case, because Morphia especially does not support the aggregation framework, at least the version that's released isn't, we're actually having to store those values on the document itself. So as we add products, we will increment the size and increment the total as well. And that makes this this query, where'd you go? MongoDB. That's where we get this one, and it makes it very simple to do. So if we're looking for, that's using the straight Java driver, and it's a good chunk of code, and you have to make sure you remember to match up document names with what your code might happen to be. Yeah. So once we get it, we're going to iterate and create. We're going to deserialize those into our objects, and that's all mostly manually. This constructor is pretty straightforward. You call it get. And pull the data out. And that's, like I said, a lot of people use the Java driver directly for a number of reasons, and that's perfectly viable, but you do end up doing a lot of the work yourself. But you have an option to use Morphia, and this is what that same query looks like with Morphia. We're going to create a query with a product order. Morphia is an object document mapper. I like to describe it as Hibernate for Mongo. And that's mostly accurate. It probably overstates Morphia just a little bit because Morphia doesn't attempt to do quite as much as Hibernate does, perhaps. But it is a type-safe library. I call it type-safe-ish for a number of reasons. But it's type-safe in that you can pass in product order and you know you're going to get back product order. It's type-safe-ish in that you're passing in these strings for field names. Now, what Morphia will do, a lot of times whenever you have something in your Java code, you want to call it something else in your code because you want your code to have descriptive names so when you're reading it, you can make sense of what it means. When you're storing a lot of data in Mongo, every field name gets duplicated. And so what some people do is they will take abbreviations of field names inside the document. So when they store it, you're duplicating much less data because if you have a billion records or a billion documents in your collection, every time that field name shows up, you're seeing this big long string. So people tend to shorten those. But what Morphia will do is it will look, you pass in the word total, And it will map either to the Java field or to the document, the document name, because you can do, in this case, if you wanted, for example, you wanted to rename order date. It's out of date. You could, in this case, rename the field to something else. And what, or to follow the example here. So you could pass in total to your query, and Morphia will look for a field called total, and it will map it properly. But you could also have passed in T, and it will map that properly as well. So Morphia will actually take care to make sure that you have at least one of those names correct, either the Java field name or the collection or the document name, or the field name in the collection. And it will also actually validate that for you. So if you pass in some random whatever, this will still compile, which is unfortunate, but it will validate it at runtime, and it'll tell you, I don't know what T3 is. But Morphia will do that, whereas the Java driver itself will not. So yeah, and then we went order by total, and it's just that simple. We actually didn't order up here because that starts getting complicated. And then you just call it back call as list. If you're not getting a lot of data back, you can call as list, and that's fine. But like it suggests, it will pull everything into memory. So if you're pulling back a large number of documents and you call as list, it will probably saturate your machine because it'll pull everything in. You have another option to do so if you wanted. You could call fetch, and that returns an iterable. So you could iterate it the way you would up there. The thing to make sure about this iterable is actually something else. It is actually a DB cursor. DB cursor implements iterable. So it's convenient to call fetch, and then you can iterate, and it's all nice and clean or whatever. But you have to be aware that there actually is an open cursor, and if you don't do anything with it afterwards, you can leak resources, just like you'd have to close your connections in JDBC. You'd want to do something with that as well. I think we're fixing this in the 3.0 driver to be, instead of an iterable, we have a Mongo iterable, which has methods that you can then call close. Because right now your only option is that you have to know that that's a DB cursor, then you have to cast it so you can call the close method. And that, I don't know, we start to leak implementation details out at that point, and it's not the most user-friendly. But if you wanted, you could certainly do a fetch, and then you could process each one individually and spare yourself a little bit of memory. Now, there's another project that I'm actually not affiliated with, so I'm not just promoting stuff that I work on, called Django, which is quite interesting, and I just lost my method because the find order's over. Now, I actually found Django because I was looking for something similar. If you're working in the Mongo shell, you get used to a query, like I want to take that query, I want to do that. But the Java driver doesn't support it, and Morphia certainly doesn't. But with Django, you can actually recreate the actual query syntax in your Java code, and it will do a mostly good job with it. There's one caveat: you can do regular expression queries, which break the JSON mold even more. Django actually uses Jackson under the covers to take that string and parse it into a map, because Jackson is forgiving about not having your field names quoted the way JSON technically requires. So if you're using regular expression queries, it breaks because the query would look something like this, if that were a string. And then everything inside those slashes is a regular expression in that type of query, but that doesn't parse. So that actually Jackson will throw a nasty exception because that's really not not JSON. So if you're not using regular expressions, Django is awesome. You can take your queries that you've tested out of your Mongo shell and put them straight into your Java code, and they just work. Now, this is a placeholder. That's the syntax Django uses. So when you're done, you then pass in. It's a little bit like the format strings. In some ways, you just have all these slugs in your string, and then you have a list of values that you want to then merge into your string. And that's what this is doing. So here's our query. This is a parameter placeholder, and we want to put in the total. And then you can call .sort. And what's nice about Django, the examples actually use, I think they all use DB, but it starts to look a lot like your query in the shell, because everything is db.collection and then some method, in this case find. So it starts to look very, very similar. So if you do a lot of switching back and forth, this can be great because it's a little bit of less context switching because it's a very similar context. And then with Django, you can call .as, and it will, again using Jackson actually, it will deserialize the map that comes back into a product order. Now, why is that red? Doesn't matter. Now this next one is actually, I should give a little bit of history. I've been with MongoDB since about June, so 5 or 6 months now. I haven't been working with Morphia directly for very long, and I was annoyed with the whole type-safe claim that Morphia makes because it's, like I said, it's mostly type-safe. So I started a project called Critter, and without trying to self-promote too much, what Critter is, it's an experiment that, as part of the compilation process, it can see your entities. It'll find all the classes you have marked up with entity, and it will generate classes. And it mostly works. It breaks in all the ways I expected it to break, which is kind of why I wrote it. But what it does is it creates methods so that I can call order date. And I know that's hard to read, and it's a lot of code, and you're not really intended to read it because it is stuff. But, and it exposes some of the Morphia internals. But what's important about order date, about these methods, is that they all are literally type safe. None of these take parameters, so it's kind of a bad example. But let me find. So what happens is this generates code so that it only takes parameters for that type. So I can't pass in a string for an order date, and I can't pass in a number for a name because of the way the API works out. And that gives it a layer of type safety because whenever you're looking, you don't have to guess the field name. If your field names change in your Java object, that criteria class actually changes as well, and your code will no longer compile, which is mildly annoying, but it does catch at compile time that your structure changed, and what would have been a broken query that you'd hopefully find in the unit test that you hopefully wrote, you actually find them at compile time because it can't do anything with it because that field no longer exists. And where, like I said, I mentioned the whole hair color thing. In this case, user has no hair color, so it actually breaks. It literally won't compile. But as you can see here, with a straight Morphia query, we're asking for a user with hair color equal to whatever color that is. And this will actually work. It'll run Mongo. If you ask Mongo to query against fields that don't exist, it's okay. It'll just move on. It'll just return you no documents. So instead of getting an error because your query is broken, now you get 0 documents, which may be what you wanted, but not necessarily what you expected. So Critter attempts to fix that by actually generating an API that will not allow invalid queries. And in fact, if we wanted to do find orders over. So in this case, you can see we're looking for total greater than or equal to, and we're passing in, we have to pass in a number. If I were to pass in a string, it actually wouldn't work because that method, greater than or equal, will only take numeric types. It was a little bit of a thought experiment that I started before I joined MongoDB, and it may or may not make its way into Morphia itself. Yeah, when your code changes, it can make migrating kind of a hassle. So I'm not sure if Critter will work out necessarily, but it was kind of a fun thought experiment, and I still use it actually on my own stuff, but I don't know if it's quite ready for inclusion in Morphia. So there is those are some basic finds that we just saw. They're actually quite simple on the Mongo side because we don't have joins, we don't have the complex stuff. Here's another find with the Java driver and Django as well. Now, what I want to show you, because I have a fair bit of time before we get to questions, we have what's called the Aggregation API, and I have it in a browser tab, but it'll take me a second to find it. But what the aggregation framework does is it exposes a number of operations, so you can do things like, I want to group by these fields, I want to sum this, or I want to take the mod of that, and it lets you do those kind of more complex queries. This code was not set up to use that because Morphia doesn't support it. At least it didn't when I wrote it, but I've been trying desperately to get it done because I'm working toward a 1.0 release of Morphia, and I want aggregation support and text search as part of the Morphia API. So if I can bring up the right project, this is Morphia. I was actually looking at someone else's problem earlier today. You will literally be the first people beside myself to see this code, because I wrote some of it on the plane here, and then I wrote some more of it yesterday in a session. So let me find what the aggregation stuff looks like. And it's gonna. All right. This probably just screwed up on the display there. Aggregation. Let's look at an example. So in this case, we want to find this is all up on the MongoDB site, so you can download all of this. In this case, this aggregation is trying to find all the states with populations above 10 million. And there's a BSON file at the top that you can download that has all this data that you can import. So this is what it looks like to do an aggregation. You can do db.zipcodes.aggregate, and then you give it what's called a pipeline. And a pipeline can have a number of stages. In this case, there are 2 stages in this pipeline. We're going to do a group. We're going to group it by the state. And every group has to have an ID, so that's where you see the underscore ID. The $ here, it gets a little tricky, and I don't necessarily want to dig into it, but unless people are terribly interested. If you just pass in a string, it just gets passed right along as part of, as like a data value. But the $ here inside the string says, this is actually a field that I want you to go look at. In this case, it's a property of a document inside the zip codes collection, because every document has a state, of course. And then we're going to, in this case, create a new field called total pop, which is the value of this function. In this case, we're going to sum the population. So in the collection, there are hundreds and hundreds of cities from different states. So we're going to group them all by state, and for every city within that grouping by state, we're going to sum their populations, and we're going to store that value inside this field called total pop. So that's the group, and in this case, now once we've done that, we've generated a number of documents, probably in memory, depending on how you do this. But we have all these documents now, and we have, I guess, 50 of them, because they're states. So here we're going to do a $match, which is basically the query. The syntax is just like the find syntax for the most part. There are some limitations, which I can talk about, but you probably haven't seen them, so they won't mean much to you at this point. But in this case, we're going to do a match, which is just a query on the field total pop, which we just defined, and we're going to do this function, $, and then 10 million. So that's what an aggregation looks like. So if I were to do my order demo today, if I were to start writing a new application, I might think about doing it something like this, because now I can add up the orders at query time and find them, instead of having to manage that manually. So this does come back with a number of documents, and this is what it looks like. We have the ID, as you can see there, we define this ID, and we have a field called total pop. And then we have, I think, 7 come back from that. So that is what an aggregation looked like from the shell. And so the demo didn't do that because Morphia didn't support it, and it'd be a huge chunk of code. But I am happy to say that as of this week, Morphia is starting to support it. The API is very small at this point, because I'm literally recreating that example, the 10 million states. I'm using our aggregation documentation as as the basis for what tests I write, mainly to help flesh it out, but also to give a nice transition. You can look at the documentation, see what the shell looks like, and then you can see the exact same query in what Morphia looks like, and you don't have to do all that mental translation. So there is one caveat with this, that this API is, like I said, it's brand new, it's under development, and it might look very, very different over the coming weeks, but hopefully not months, because hopefully it'll be done by then. But it'll be in the next release or the release after that in some form. And I would love for people to play with it and tell me what was wrong with it, because I'm pretty sure I screwed something up, because most APIs are wrong the first time out. But let's move on. So we create the aggregation, and we're going to give it 2 classes in this case. Unlike a query, we know exactly what we're getting out because that's the collection for that particular document. So we're going to give it 2 types in this case. So there's a city type, which we've defined down below, which is the zips.bson file that you download. It's literally ID, name, location, population. That's the stuff that you imported. But when we're done aggregating, we're actually going to get back a subset of that because we're doing the summations on the data. So in this case, I created another class called population, which has 2 fields, state and population. And as you can see here, I mapped it with property, because in the document that comes back, we called it total pop, remember, in our pipeline. But in my Java code, I don't want to say total pop all the time. I just want to call it population. So just like mapping queries, you can rename fields with your properties. So that's what our grouping looks like. Here's state. In this case, right now, I'm assuming that when you pass in that string, it's a field, because I don't necessarily like the idea of you guys having to know, oh, I need to put a $sign in front of that state there. That may change as we start building out more complex examples, because the group can appear kind of anywhere. And right now, I can validate that state as a field on city, because group is the first stage in the pipeline. But I won't always have that liberty, because you can actually do projections as well. So you can say, I know I'm going to the cities, but I want to get these 3 fields, and that's it. And then you can group by those fields, and you can actually rename fields and projections. So it might end up being at some point that you have to know to pass in the $sign, but I'm trying to avoid that because it's not very, very nice to look at. So, but we're going to group. We're going to give the ID of state, and we're going to, in this case, I'm calling it field. Not a huge fan of the name just now, but I had something to work with. So, and it takes a name and then an accumulator, and then the accumulators are basically sums and mods and all the operations that you would expect to do on that. So that's one line, which is basically equivalent to this part of your document. And it should look, I'm trying to make it look as similar as possible, but it may not quite work. And then there's the match, and we're going to match on a field called, and I know it repeats .match and then match. Also not my favorite, but I'm trying to find a nice readable way to present the API, and that's what I'll need some feedback on if you guys want to try it. But in this case, we're going to match total pop and greater than equal, and it takes that. Unfortunately, this is also, we're back into type safe-ish. It takes an object. So I could say that the total population is greater than hi there. And that compiles, and it won't work because hi there is not a number. So there's that. And then you call aggregate, and then you get back. In this case, as you can see, we have the Morphia iterator instead of just straight iterator. And that was a conscious decision. It makes it a little bit inconsistent with what's there now, but it's the nicer way to do, and it's where we're going with the Java 3.0 driver anyways. But it is an iterator, and you can just run across and you can print out the stuff. And as you can see here, I actually closed that because it is an active cursor. So that is the beginnings of the aggregation API, and I wish I'd had it months ago for the other stuff, but hopefully in the next month or 2 I'll be able to finish that out, and you can do some pretty amazing stuff with Morphia. And we have about 15 minutes left now, I guess. So, and I don't think I have anything else necessarily to talk about. Let me just make sure, because we covered the queries and we went through a lot of code, and that didn't do what I thought it was going to do. I want my slides. It's there it is. Right. Oh, I did want to mention there's a pillar in our office with whiteboard paint on it, so we can draw on it. And one of our developers is apparently a fabulous artist. So she drew this. She did it about the time when Grand Theft Auto 5 came out, and I don't know if it was a big deal here in Europe, but it's like all anyone talked about in the US for a while. So she drew this on the pillar one day, and I put it up here just to point out that this talk was about Java, Morphia primarily, but I did want to point out with Mongo we have these languages you see here. Those I think are all ones that we are actively working on. So there's a C driver in C++. We have Node.js, Scala, Perl. We have a Go driver, PHP. We directly write 12 drivers in, I think, 12-ish different languages, but we either support in one form or another or assist community-driven drivers. So we have probably 30 different drivers, 30 different languages represented. So whatever your particular choice of languages is, if it's not necessarily Java, you can probably find a driver for it in whatever language you want. And if you're a polyglot shop, it's especially nice because then you can use that driver as well. But I did want to throw that up there in case there were people who were more interested, like, I prefer Scala. We do have one called Casbah, there's Reactive Mongo, there's a number of different Scala options as well. Just some quick links. This presentation is actually up on GitHub. All the demo code is up there on GitHub. Every last bit of it is. So if you want to look at it and play with it, it's all up there. MongoDB, of course, is the homepage for Mongo. MongoDB.org, I should say, because now MongoDB.com goes to the corporate page. The Morphia is up on GitHub. Please download, clone it, try it, file issues, pull requests, whatever. You can find Django at django.org. They just actually had a couple new releases that I haven't really quite looked at yet, so that's still going active. And if you want to look at Critter, it's there. It's my stuff, and I'm trying not to pimp it too much, but there it is. So I'm going to attempt to see hands and answer questions, should we have any, and we have a few minutes left here. So, questions? It can be about Morphia, it can be about Mongo directly, and I'll try to answer whatever you have. So, no? Quiet group? Oh, I see one. Yes, you can do aggregations on shards. There's a process when you do sharding, not to get into too many details, a process called MongoS that you actually communicate. Rather than talking to the MongoD directly, you talk to MongoS instead. And then the MongoS will take whatever query you put into it, in this case aggregation, and it knows where the shards are, it keeps track of the shards, and it will send that particular request to whichever shard needs to handle that particular data. So you shouldn't see any differences in capabilities, at least when you start to shard. Yes? I can't quite hear you. Well, I guess the official answer is that it's really fast. It's kind of a harder question to answer non-glibly because it depends on so many things. There's a number of things you can do to make it really fast in a number of different ways. Mongo does try to keep the working set in memory. It actually uses memory mapping in the kernel to map the space on disk where the data is stored into memory. So if your working set is in memory, it can be really, really fast because there's a lot less disk I/O. Typically, you give a MongoD instance a machine with lots of RAM and just turn it loose. So reads can be very quick in that regard. Writes can also be very quick, and it's kind of dangerous ground. But Mongo supports what's called a write concern. And a write concern is basically a way to tell Mongo how concerned are you about this data. For a while, the default write concern was, hey, I put it on the socket to the server, I'm done, we're out of here. Which made it really, really fast because you write data to the wire and then you're done. But of course, on the other end of it, the server has to receive that data and it has to write it to disk and it has to do all this other stuff. And if you're not waiting around for all that to happen, it looks pretty fast. The default write concern now, as of the last round of driver releases, is it's W1, which is kind of the implementation detail, but it basically says, I want the server to confirm this, which usually means, I think it means it made it to the journal. Don't quote me on that one. But we have, once it gets to the server, we have kind of two different phases of it. Like most modern databases, we use journaling to keep track of all the requested operations, so that if something should fail, it can replay that journal and not lose a whole lot of your data in case of, like the server just suddenly powers off for whatever reason. So there's a write concern that says wait for it to get journaled, wait for it to write to disk, which is the safest because it's down to your physical hardware. And in terms of when you start talking about replication, you can actually say, I want to wait around until all the secondaries have seen this data. And the more concerned you get with your write concern, the slower it's going to be, obviously, because it has to wait for so much more. So that's kind of a long-winded way of saying, well, it kind of depends. But it can be as fast as you're comfortable with, or as slow as you need it to be to feel secure with your data. But for the most part, once it gets to the server and the server accepts it, you're good. There aren't any, last time I checked, there are no data loss bugs open. No one's reported anything, so I know there's a lot of concern and a lot of blog posts or whatever, but it's mostly unfounded. So, did I answer your question? Hopefully, okay. Anyone else? Yes. With Django, I hate to comment about another project, but I want to say yes, it's probably possible because you're sticking in random strings. But I will say on the Mongo end of the world, which is probably where Django gets the safest, it's actually pretty difficult to do a SQL injection style attack just because of the way the query stuff works. That said, when you're doing a query, there is a $where clause, which is a way you can actually pass in JavaScript, just a random chunk of JavaScript, and the server will actually execute that as part of the query execution. And that can be useful in certain scenarios, but it is, of course, at that point, you're exposing your server to random chunks of JavaScript. So for the most part, SQL injection isn't terribly a huge concern, because the query engine just doesn't work that way. But if you do ever use $where or expose your query strings in such a way that someone can rewrite it through malicious content, it might be a possibility, but not generally a concern. Anyone else? Anyone? Okay, well, that's it. If you have any other questions, feel free to walk up and ask. I'm happy to answer anything that I can. And that's my talk. Thank you.